Hi, this is Lena Lee, Global Commercial Product Manager for the ViCell product line. Welcome to this short presentation on transferring cell counting methods, recommended steps to matching results. There are many reasons that drive adoption of a new method. It can be obsolescence of equipment or materials. You might need to increase your throughput, or you might need to decrease the variation in your current process, or just general process improvements. In our example, we recently released a new instrument called the ViCell Blue. So when customers are transferring their current method to the ViCell Blue, they may need to perform bridge studies or correlation studies in order to migrate their existing method to the new instrument. In this presentation, I will provide an example of a step-by-step approach on migrating a ViCell XR to the ViCell Blue. In getting started, it's important to first verify the performance of the cell counting methods to be evaluated. There's a protocol outlined by NIST called Evaluating the Quality of a Cell Counting Measurement Process. In this paper, they outline how you can use a dilution series to assess instrument performance. In addition to using cells, you also want to utilize standardized beads for concentration, viability, and also size. These are independent of cells, so they give you a better baseline indication of instrument performance without the variability that you may get from live cells. You can also leverage a reference cell counting method, such as a Coulter counter, like the multisizer or Z-series, or even hemocytometer. But hemocytometer adds another level of variability. But in altogether, it's very important to verify the counting performance of your method before you get started with optimizing and doing your correlation studies. And here we will begin showing you examples of how we were able to match cell counts between a new cell counting analyzer called the ViCell Blue and its predecessor, which is called the ViCell XR. Both models are fully automated cell viability cell counting analyzers. They both utilize the trypan blue dye exclusion method. The ViCell Blue is our next generation cell counter from the ViCell XR. The ViCell Blue was designed with the flexibility to adjust the cell type settings to correlate or match with an equivalent sample that was also run on the ViCell XR. This was very important in our development of the ViCell Blue. We want to note that complete matching may not always be possible. In some cases, some cell samples may have higher variability. This can be due to either lower concentration samples or lower viability or clumpy cell lines. These can add a higher level of variation. But in general, it should be possible to match the performance between your instruments or methods to get an acceptable level of matching. Here we will show you a step-by-step process that we used to match the ViCell Blue and the ViCell XR using typical cell type parameters for a representative cell sample. In our testing, we were able to achieve concentration results that were within 10% of each other and viability within 5%. The first step in our method for matching cell type parameters was to ensure that the counting performance for the ViCell XR and ViCell Blue was verified using their recommended standard beads and protocols. After we verified that both instruments passed their concentration control standards, we then moved on to run a common concentration control sample on both systems. So the same sample was run on both instruments. In this case, we used the Vicel XR concentration control, which is about a 1 million bead per mil sample. Alternatively, you could use different bead concentration standards as long as their concentration were determined using a particle counter such as a multisize or Coulter counter. And we want to verify that both of the instruments using this common concentration control did present a result that was within 10% of each other. This helps us get some confidence that both instruments are in good counting accuracy. And so if they're further apart than 10% of each other, we would want to troubleshoot a little bit deeper to understand where that difference is before we proceeded. Once we're sure that both instruments are counting within 10% of each other, we then can begin to run live cells. And here we recommend to use cell concentrations that are greater than 2 million, so you have a good representative count, and greater than 50% viability. So there's not too much debris in your samples. And when you are running these samples, you want to run the same sample side by side on both instruments. So they're run as close as the same time to each other, just to decrease that variability. We also suggest to run samples in replicate. Perhaps triplicate would be good. This will help to improve the statistical confidence. Use the appropriate cell type for measuring the cell sample, and then save the images. This way you can reanalyze the data without having to rerun the samples. In our testing method, we use the CHO cell line. We ran the same samples on 3 Vicel Blues and 3 Vicel XRs using their appropriate cell types. Our goal was to match the systems within 10% of each other for concentration and 5% for viability. You can definitely determine your own degree of matching, but these are typically as tight as you would want to go. If you want to have a tighter correlation, which is definitely possible, but not always realistic, just because of the tolerance stack-ups between the process overall of counting, sample prep, the samples themselves, can add the variability that, you sometimes cannot get any closer than 10% for concentration and 5% for viability. Here I just want to give an overview of what cell types are. Here is an example of parameters in a cell type from the Vicel Blue. The cell type is a collection of settings that control the sample preparation and analysis parameters. The cell type includes the number of images to use in analysis, the sample prep settings, which are the number of mixes that you might have for your sample, also the cell count threshold and the viability threshold. This table shows the cell type settings that were used to do our correlation study. These are settings for the Vicel Blue, which was the mammalian cell type, and the CHO cell type for the Vicel XR. With the cell type settings that I just showed in the previous slide, we were able to demonstrate that we could optimize the cell types on the Vicel Blue to correlate the concentration results to be within 1.7% of the Vicel XR and viability within 1.1%. And and the average diameter of the cells were also less than 2% difference from each other. So to just wrap up, our recommendations are that you utilize concentration and viability standards as part of your study. Use cell samples that are greater than 2 million cells per mil in concentration with higher than 70% viability. You also want to practice good sample handling. Test your samples side by side so they're run as close in the same time. Practice good statistics, run samples in replicates. And you want to account for variables in the process, set realistic tolerances. And you should be able to determine this based on your counting performance that you would have done before you started your correlation studies with the two methods. And then definitely account for differences in technology. In our example, the Visol XR is an instrument that was out on the market close to 20 years ago versus the Visol Blue, which has very recent technology. So you will have some differences in the technology that can add to the differences within the two methods. And for more resources, you can always go to Beckman.com. We have a page with all the different cell counters and analyzers, our multisizer, as well as our Visol Blue, Visol XR, and also the Visol Metaflex if you were interested in media analysis. There's also a page on our website that has cell type guidelines to help you with cell type optimization. Thank you for your time. If you have any questions, please feel free to contact me at Lena Lee at Beckman.com.